the speaker of today is Alberto Nicoletti, who will talk about, from Group of Us, who will talk about the Aura project. So, thank you, Alberto. The floor is yours.
Thank you. So, well, of course. Hello, everyone. I am Alberto Nicoletti, as I was introduced, and I'll start by thanking our gracious host, as well as I'll thank you, the public, for being here. So today I am presenting to you this smart box developed by our company. The presentation will go as follows. I'll start by a brief introduction of what the actual project is about, so what the goal was actually with this smart box to be developed. Then I'll move on to the architecture overview, meaning basically the hardware. I've prepared a nice picture for you to show where it is clear the various different components that make up the entire device, IoT device, because we are talking about those. After that, we will move on to the more, let's say, software part, which is the collection of data produced by this device, and then last but not least, the display of the produced data in a web application, which can be seen either on mobile or on the web, obviously. And finishing off, I'll conclude with naming, well, obviously the advantages of this solution, as well as the possible future that this product can have. So, let's start first with a brief introduction to Aura. You can see this picture on your left is, let's say, a prototype of our device. It is actually more of an adaptable design. It's not the finished product. We have one of those looking exactly like that. But, for example, the picture on the left is the actual device integrated in this furniture, this green furniture, which was displayed, for example, in this case, is at Futuro Remoto, which is another convention in Campania. So, the goal of Aura, of our smart box, is to integrate the IoT technology, so basically our hardware, with the urban green furniture. You have to keep in mind that this is not, let's say, a fixed design. It's more, we have the hardware, we have, let's say, the sensors, the box, which can be adapted to various different solutions. The goal of the entire project was to develop this solution that integrates well within, that blends in actually with the green furniture of a city, for example, of everything around us. We can be in a park, and the goal of this integrated green furniture is not only to contribute to reducing the pollution, the air pollution we are talking about, but also to monitor it and to use the produced data for obviously processing, which could be, for example, who knows, a weather alert, look out, the air quality is pretty bad here, don't go there. Or also for breaking and monitoring the heat islands that obviously show up in the cities. So namely, when a city becomes too hot, you can monitor the temperature and develop solutions to counter this phenomenon. So, last but not least of the 3 points of the key features is the low commercial components, which is still an important aspect because we wanted to develop a solution which is on a budget, let's say, which is not too pricey to be installed. And here comes in also the open software and the open, let's say, part, because working with open hardware and open software allows us to reduce significantly the development time and also obviously the build cost also in time, because you don't have to design everything from scratch. Instead, you can get your COTS, your commercial off-the-shelf components, and then integrate them into the solution that suits you best. And our solution was this one. So, moving on, we start with, let's say, the architecture. Here is the picture that I was talking to you about. This is the actual, let's say, hardware that composes the brain of a single device, we do not cover the, let's say, green part, because depends on the implementation. But the most important part of this whole ensemble, well, we have on top, we have the battery. Let's see if it works. No, sorry, wrong button. Spoilers! I was wondering whether this button would work. Well, I can just describe you. Well, on top obviously is the battery, which is self-explanatory. What is most interesting instead is all the sensors. In the bottom left corner, there is this Grove all sensor environment, all-in-one environment sensor. I'm not here to advertise anything. No. I am just telling you that these are the core components that make up our device. Simply, we have this sensor which measures humidity, temperature. Then on the left, we have the gas sensor, which measures, for example, the concentration of nitrogen gases or ozone. Then we also monitor, for example, CO2, carbon monoxide, the powders. Sorry. Well then, this is what concerns the sensing part. After harvesting, let's say, after gathering the data from our environment, we need obviously to send it to somewhere else. And for that, we have obviously a device, a connectivity, Wi-Fi and Bluetooth. Bluetooth is mainly used actually for configuring the device, not actually for sending, because we are sending the data via MQTT. So to our central server, and there comes in also the Wi-Fi. Last but not least, as you have seen before from this first picture here, on top we have this solar panel that allows the system to be independent, autonomous. So we don't have to wire it to anything or change the battery. Which is very useful in a city where you don't want to go like with the light bulbs and having to change them one by one. So last but not least, we gather this real-time data and send it over to our server. You have to keep in mind that the data that it is harvested is basically environmental sensors, but not only of the, let's say, air, but also of the plants, because I may have left it out a little bit, but we are working with plants, living beings. So we need also to keep track of and monitor the work, quote, let's say, they do, because they have to act as a biofilter for reducing pollution in the air. Now, moving on to the first part of the software. As I mentioned previously, our data gets sent to our... I got lost. First, we have to cover the software part of the device itself. So it's very simple, let's say, put it like that. It's not actually that simple implementation-wise. We got the single drivers, and we had to basically orchestrate them into the actual activity of the device, because we need a device to start up, obviously, check that everything works, and then if everything works, record the data, send it to the central server, and then it can shut down, because we don't want to keep the device powered up all the time for obvious reasons, since the solar panel can only work at day, and at night you can do some measurements, but leaving the device running the entire night may deplete the battery. So basically the software works as follows. As I already named the various phases of the, let's say, life cycle of one capture. It's important to add in that the device, if it encounters any issue, it will stop. It won't send partial data. For example, if it fails to connect to the internet, to connect to the central server, it's going to shut down. It's going not to record any data. So we have, after checking connection. It makes this calibration, so prepares the sensors for measuring, collects the data, and then sends it over to the server and the MQTT broker using a JSON format, which I've included in the next slide, which is this one. So basically, it's a very quite self-explanatory, not the labels, but the data it is. We simply broadcast the name of the actual device, so the identifier, to be precise. The name is GN Aura, so for display reasons. Then we have the core part, which I've included just a snippet because the data is in a standardized, inside the PV object, we have this standardized format. The name of the value, the actual value, and its unit. This is useful very much for displaying then the data in our web application. The data is sent retrieved from the various devices, and we, once it arrives to our server, integrate it with data from the public APIs. For example, we could use the civil protection, ARPA, or open weather. You choose one, or more, obviously. The data is stored inside a JSON data lake, so we do not directly process it. We process it only when we query this actual ensemble of data. And it is very useful, this, because it allows us to reduce we do not prepare everything already. We keep the raw data stored, and then we process it when we need it. And last but not least, it builds a data history for trend analysis. So meaning that we can visualize the entire history of, let's say, temperature for that specific device, which in turn means that that device has recorded that data in that location, and we can then build onto that all the different maps. You choose what sort of mean for conveying actually the data to general public, for example. So obviously the last part is the data display. I've included a couple of snippets from our web application. For example, here comes back again the open software part rather than hardware, using obviously available libraries like Bootstrap for displaying the data in a responsive manner. And then here you can see also an overview, very basic. For example, on the white card, you can see the bulletin from the civil protection for alerts. For example, if there was a weather alert, can be implemented to be shown on our application. And also on the leftmost image, you can see the quality of the air quality index, which is a very important data, but obviously not only that is displayed, but also, as I named previously from the sensors, the ozone, the humidity, temperature. You choose. We have introduced a lot of sensors, and I think that the presentation have embedded actually the sources to that in the presentation, so you can see all the various different sensors that we used, because obviously on the presentation I cannot include the entire list of sensors and what they do for obvious reasons, since I have less than 1.5 minutes left. It is obviously when dealing with front-end and mobile application in particular, it is important, if not fundamental, for modern application to be user-centered, meaning it has to have a very intuitive design, clean, and doesn't have to basically lose the attention of the possible stakeholders, because we are not just talking about general user, but we could also use, our users could also be the public administration, for example. My last, second to last actual slide is the advantages and the extensions, which is very important as a thing of this project. So we, as I have already said in the first slide, we are integrating the IoT part with the pollution, the biofilter part. So it becomes This it contributes to reducing actually the pollution and breaking up the heat islands that form in the cities using the green furniture. We can monitor the situation of the city, so the heat, temperature, if it's in a city it's too hot. Obviously, okay, I'm almost done. Just not even 1 minute. Well, the open source is, as I said previously, very useful for reducing time and money costs. And obviously the opportunities are endless because we could expand the reach of our network of sensors or enhance our predictive analysis like our models for modeling data, or simply allow also public access to the data produced. So I run out of time. If you have any questions, I'll be available here this afternoon, or you can write me to my email address. Thank you for having followed me, and it was a pleasure for me to present this.